Okay, so we've talked about the batteries being the base of the system, and then the solar panels being one of the energy sources to feed the battery.
Correct.
And then you have a charge controller in between those two to manage the amount of energy going into the batteries.
You do.
Okay, and then and we talked about the inverter and the inverter's role in the installation. So let's talk a little bit about putting it all together. What's your favorite brand for putting this all together?
Well, I personally have taken a liking to the Victron equipment. They make a very nice battery monitor, which we started with, and they have a smart shunt or the BMV 712, and both of them use Bluetooth. They have a great app that you can run on both Android and Apple, and it gives you a lot of information, which both helps me if I'm troubleshooting someone's system or I'm teaching someone how to use it. It gives them a lot of information. And everything can tie together over Bluetooth. Their charge controllers, the battery monitor, the inverters can all sync together with Bluetooth. And then they have a next level that's called the GX device, and their Servo GX is their latest one. And this kind of ties everything together on one screen. You can see, you've probably seen, if you've seen anyone share the Victron stuff, they probably shared the Venus OS, and it's a neat GUI that shows you all kinds of stuff. And it's also able to be uploaded to the cloud. And so again, I can do remote configuration on someone's system. I can jump in and I can tweak stuff, or I can look. Nothing wrong with other equipment. It's just sometimes it's a little tougher to use. There is budget prices. Of course, some people would prefer not to, spend quite the money. Sometimes that Victron equipment might run over other stuff, and that's always just a preference of theirs. But okay, I do enjoy the Victron equipment the most. I think they do a good job with firmware updates and keeping it up to date with new features.
Okay. Yeah, and you mentioned earlier that it gives you so much information that you're able to better diagnose a particular problem that comes up in the system as opposed to some systems.
Yeah, and especially if it's some just equipment I'm not familiar with. There's a learning curve to it. Sometimes it just doesn't give you the information that I'm really looking for. So okay, I am most familiar with Victron, and it's what I enjoy supporting the most.
Okay, all right. So great. So let's go from there. Tell us how you connect all these pieces. What are the components that go into a good design for RV solar to connect all the inverter, the batteries, the solar panels on top? Tell us about that.
So early on, we talked about the shunt and the battery monitor and how they work. And basically, the shunt measures all the amperage coming through your system. It's how it knows the state of charge. And one of the things when you introduce a shunt to your system is you need all the power to go through the shunt. So that usually involves using a bus bar in your system.
So what is a bus bar?
A bus bar is basically a piece of equipment that has several connections on it. And so you can connect your batteries to it, you can connect the charge controller into it. And so instead of connecting everything to the batteries, you're going to the bus bar. And the reason is that now you can put the shunt between the batteries and the bus bar, and all loads go through the shunt. And that's your end goal, is to make sure that all your negative loads go through the shunt. And the purpose of the shunt is exactly what? It basically counts the amps going in and out of your system. It's a known resistance, and it's able to calculate accurately how many amps are going into the batteries or how many amps are coming out of the batteries. Okay. So instead of using voltage as a possible way of state of charge, is actually counting how many amps go in and out of the battery, and using some algorithms, it's able to accurately measure your state of charge of your battery. Okay, and without a shunt, I mean, are there RV solar installs that don't use a shunt? There certainly are, and people, voltage on lead acid, you can kind of get away with it for a little while. Lithium is really tough because the voltage is so stable. There's only about a 0.2 to 0.3 voltage difference on 80% of the discharge of a lithium battery. So it's really hard to know if you're at 80% or 20% without a shunt in the system telling you. So it's definitely a strong piece I recommend. It also can tell you if you have a high load you aren't expecting. You might see, I've got a 10 amp draw in my system, what's going on? And you'll start to pick up irregularities like that if you have a shunt, and you can see that kind of stuff. Okay. And the shunt is tied directly to the battery monitor. That's really what the shunt is, the battery monitor. Okay. So you mentioned a bus bar. Tell me more about the bus bar. So one of the systems I like to use is the Victron Lynx Distributor, and it's a bus bar that's got included fusing in it. It's got 4 separate connections, and it makes a really clean install. So instead of having separate fusing and breakers on different places, you've got one unit that everything goes to, and it really, I like the way it works on a lot of systems. Unless there's a space issue, most of the time that's the way I design systems. Okay. If they aren't using the Lynx Distributor, then it would just be bus bars. An important aspect people sometimes miss is how many amperage, how many amps the bus bar can support, because that is all your DC loads are going through the bus bar. So it needs to be adequate size, especially with lithium batteries that might be pulling 200 or 300 amps on a heavy load.
Okay. All right, so that covers some of the basics. So let's talk a little bit in detail about fuses and wiring, because I've heard that you need a specific size cable or at least some sort of size cable. What does all that mean?
So definitely, when you're designing a system, you have to be able to support the largest loads, DC loads coming off the inverter, which is usually your highest draw. And that's coming from the battery. So between the batteries and inverter will definitely be some very large gauge wire. A lot of times this is 2-aught or 4-aught wire. And you're fusing to protect the wire. Some people think you're fusing to protect the device, but you're actually fusing to protect the wire. You don't want your wire to become your fuse. So you have to, there's charts out there, or just talking to someone knowledgeable about different things. You can look up what the specs are. Wire lengths come into play, the type of wire, the rating of it, all come into play, and then proper fusing. And of course, if you're doing the solar side, you got to keep the voltage in mind, because you might be running a little bit higher voltage coming from the panels. And some fusing or breakers are only rated to 24 or 48 volts, and you might be coming in higher than that. So in that case, you might be doing DC rated breakers.
Okay. So would it be fair to say if you've got 3,000 watts of solar on your roof, you're going to need, and you've got a long run from the roof down to wherever you're going to be terminating that run, you're going to have a specific size cable for that, as opposed to if you've got 200 watts on your roof?
Definitely, yeah. The amperage, really the amperage coming off the panels is what matters, but definitely the length of the run and the size of the wire comes into play. A lot of rigs these days come solar ready, but most of them come with 10 gauge wire, which is pretty minimal. So if you're going to build a larger system, you might have to, use larger gauge wire in your system. But there are ways, depending on the voltage you run, if you can support that 10 gauge wire, you need to move up to 6 gauge or even 4 gauge.
Okay. All right, excellent. And if you do have a solar ready rig and you find out your wiring is too small, well, one of the benefits of having a solar ready rig is at least they've got a channel from the roof down to wherever they've terminated that particular wire. So could you use that to pull bigger wire through?
You definitely can. If they haven't tied the wire off anywhere, you could definitely use that smaller wire to pull new wire through. But at least, like you said, there's a channel already running there, and you can follow it, maybe some sort of fish tape, to get the wire down. You could accomplish that.
Okay, excellent. All right, so there's a lot of energy going on from the panels to the batteries and all throughout the system. Are there any safety mechanisms that need to be put in place in order to protect you if you need to go in and work on the system?
That's definitely a good question and something to pay attention to. Coming from the panels, you could have some pretty high voltage. I personally like to use DC rated breakers, and they can be used as a disconnect between the panels and the charge controller, so that if you are working on a system, you can turn them off right at the, before that power gets to the charge controller. And then coming out of the charge controller, you would be fusing it for the wire size. And then on the battery side, usually the same thing. If you're going to be working anywhere on the system, you want to be able to turn the power off at the battery. So usually a disconnect right at the batteries is very important. And again, it gives you a main disconnect that all the power is off, nothing is going to be on. And that's a safe way to do it.
Okay, so we talked a lot about a lot of different pieces that have to go into a system like this. And it seems a little overwhelming to me, but I'm just not familiar with it, and that's one of the reasons we wanted to have this talk, is so I could learn more about this. But let's talk about, so you want to do solar, and there are all these different moving parts to make a solar system. How do you put it all together? I mean, where do you go from here if you actually really want to start doing solar?
Well, one of the best places to start is actually build a diagram of your system. So I've included the panels, the charge controller, everything we've just discussed, inverter. You can figure out the wiring sizes, and some people I've seen draw these by hand. Some of them have access to some software that they can use. That's another place where I come in. If someone reaches out to me and they're like, here's a system I want to design, I can build them a wiring diagram. I can walk through, as it was in the beginning, we talked about tell me your story, and I can design them a system that matches their needs. And then I can do basically a full shopping list of all the parts they would need, wiring, fuses, links to all the stuff, and they can purchase it through a supplier that I use or on their own. Either way is fine. And then I can build them a wiring diagram and say this is how it's all going to hook together. And I'm there to help them each step of the way if they need it. If someone's a little more advanced and they kind of have a better idea, maybe they just want to go over their system, that's something I can help them with too. And but yeah, definitely once you get the diagram, then you kind of get a visual idea of what the system's going to look like. And of course you can start at the panels and how do you get the wire into the roof if you aren't solar ready. You know, one of the things that I like to tell people is they can pull a vent fan down in their RV and they can see what the roof is made up of. And they might see their wood's, you know, half-inch wood, piece of wood, or 3/8 or something. They'll see the foam. A lot of people worried about how far they're going to drill in, and honestly the roofs are usually pretty thick. So, and it gives them a good visual of what they're going to be going through. I like to tell people that going into a cabinet that's on the roof is usually a good space because you're dropping right into a cabinet. And if there's ever a leak, you would see it right away in the cabinet versus in a wall. And usually from that cabinet, you can either go into a wall there, or maybe that cabinet's a full-length cabinet that goes all the way to wherever they need to go, in the basement on a fifth wheel. Another popular option is the fridge vent. If your fridge is not in a slide and you have an RV fridge, then you have a vent on the roof. And it's an easy access to drop wire in, go down the fridge, down the backside of the fridge, and then wherever you need to go from there. So. And of course, if they're solar ready, then they have some wires ran, and that makes life a little easier. So.
Okay. One of the things you said earlier is looking at your roof and figuring how much real estate you have, and figuring out how many panels you can put up there, and that's all based on your story and how much power you're going to need to supply to the batteries. But if you put 3, 4, 5, 6 panels up there, you're going to have a lot of wires. How do you manage the wiring on top of the roof, and are there any tips for that?
So it's going to come down to if you're wiring your panels in parallel or series, or a combination of parallel series. I like to use a combiner box, and basically it's nothing more than a junction box you're building on the roof to bring in the different strings of panels. And it's also a good place to change the wiring gauge. You're going from 10 gauge wire in the panels, and maybe you want to drop 6 gauge wire down, and so you can use some ground bars inside that combiner box to do that. Some people might just have a roof gland and they're going to be using Y connectors, and they're going to be doing several parallel runs into a Y connector. You do have to be careful about not going over the amperage rating of MC4 connectors or anything like that, because there are ratings for those. But either way, they get you into the roof with a clean install, and you would basically use Dicor, you know, around the edge to seal it up from water intrusion.
Okay. You mentioned serial and parallel. What's the difference between the two as far as your solar panels go?
When you put panels in series, you're adding the voltage together of the panels, and the amperage is staying the same. And with an MPPT controller that can handle the higher voltage, it means you're running less amps down the wires to the charge controller, which is usually less voltage loss and maybe smaller wires. If you're wiring panels in series, then the amps are adding up together. And in that case, you got to be careful about not going over the rating of the wire. So if a roof is pre-wired for solar with 10 gauge, one way to make use of that wire is to actually do higher voltage and less amps, and then you won't exceed the amp rating of the wire.
Okay. On most RV installs, what do people do?
It really comes down to the charge controller, because the charge controller has some limits. It'll have a voltage limit on the input side. I'll even have a short circuit limit. So that's usually it's a combination of parallel and series panels. You do have to have an even number of panels in each string if they're series together. So if you're doing like 2 series, 2 parallel, it's kind of got to be the same, or 2 strings of 3 panels in each string, you know, there needs to be even numbers in each of the strings. They have to be the same. And then that's really just comes down to a design aspect. One of the aspects that come up in solar panels is about shading, and it used to be that shading was a big issue on solar panels, and it definitely is on the production. It will cut production, but it's not as big of an issue of taking out a whole series string, because a lot of panels these days are built with bypass diodes, which means if one panel gets shaded, even other panels in that series string still make their power. And so it allows the power to go through. Instead of losing like 3 panels in one string, you just lose the one that gets shaded.
Okay. So I've seen on some rigs, you know, when they're installed, the solar panels actually have the ability to tilt. Mm-hmm. So talk a little bit about tilting. How do you do that, and why would you do that?
Well, tilting can definitely help you in the wintertime. When the days are shorter, the sun's at a lower angle. So generally from late October, early November until February, March would be a prime time that most people would tilt. And it just helps you generate more energy from the panels that are already on your roof. Instead of, you know, dropping down production maybe 50%, you might get 80% of your production. Some people would prefer not to tilt, and in that case they may just over panel to accommodate the lower production in the wintertime. But if you are going to tilt, you should plan ahead that the brackets you're installing can support that, because there are some brackets where tilting is just really not feasible. But there's a lot of options for tilting brackets out there.
Okay, and that's something you would help. If someone said, I want to be able to tilt the brackets or to tilt the panels, then you'd be able to help them do that.
Most definitely, yep.
And then, so there are a lot of, like I said earlier, there are a lot of moving parts. Talk a little bit about where do you install all these? How do, is there a sort of a methodology for keeping it clean and a good install?
There definitely is a good, you want to have a good location to put everything. And if you're moving your batteries because you've got lithium batteries and you're able to move them inside the rig somewhere if they didn't exist already, then it's a really good idea to keep the batteries, the inverter, the bus bar all close together, because your DC loads are going to be your 12-volt loads with high amps. And the DC wire is some of the most expensive wire you're going to buy, especially when you're talking about 2-aught or 4-aught wire. That can run anywhere from $7 to $10 a foot. So you don't want to run of that going across your rig. So in that case, you try to keep those components together in the same area. If you're running lead acid batteries and they need to be vented, then it's not a good idea to have the components right near the lead acid batteries. They should be vented by themselves, and the components should be nearby, but not in a space that occupies with the lead acid batteries.
Okay. As far as installing the panels, you have to, well, you don't have to maybe, so I guess that's my question. How do you connect the panels to the roof? Because I don't like the idea of drilling holes into my roof. So tell me about the different types of roofs, different install options, and help me get over that if I need to get over that.
Okay. Well, one of the first things is your RV roof already has several holes in it from all the stuff put on from the factory. And when you put the panels on, and if you are drilling the panels into the roof and you're using die-core and you're doing it properly, you really don't have any more to worry about. If you're putting the panels on the roof and using die-core and properly securing them down, then you really don't have a lot to worry about. Sometimes people are afraid to do that initial drill into the roof. So I just tell them to, you're looking for a space, like I said, in the cabinet where you can drill in. You're not going to hit anything. If you're able to look up at from your fan and see what was in the roof space, and just make sure nothing is there. But I like to drill a real small hole first to make sure that you're going through, you're not hitting anything, and then you would drill a larger hole to accommodate the wires you're dropping down. And you asked about roof types, and so the TPO rubber roof is a very popular roof on RVs. If you have that type of roof, you really don't have a choice but to drill a hole and put screws into your roof. You want to secure to the wood that is making up the roof underneath the membrane.
Okay. So there's in the rubber roof, there's rubber on top of a wood structure.
A wood structure, correct. And the membrane, even though it's glued down, it's not really something that you want to depend on. So you don't want to be using VHB or non-drill methods to stick to a membrane roof. Now, if you have a fiberglass roof, then you have some options of possibly using proper 3M VHB tape or other methods that the manufacturer may suggest to attach to the roof without drilling into it. Okay. So that is an option. But rubber roof, you're definitely going to be securing with screws or bolts into the roof.
Okay. And is there a way for someone that doesn't know anything about roofs to know what kind of roof they have?
Well, the rubber roofs are pretty easy to spot. They've got a membrane on the top of them, and as soon as you drill into it, you'd be able to see that. I guess before you drill into it, but yeah, you have a membrane on the roof that is usually pretty easy to spot that it's a membrane roof.
Okay.
Otherwise, it's some sort of maybe fiberglass roof.
Okay. And you could, if the manufacturer's still around, you could call the manufacturer and just get the specs on your particular build. I know we can do that with Winnebago, and I assume other manufacturers will do that if they're still in existence.
Yeah.
I do want to circle back to one thing that we touched on earlier in a previous discussion, and that was the batteries and the energy they're receiving from the solar panels. So I've noticed on our rig that they go through those 3 phases that you talked about. So bulk seems to go really quick. There's a lot of energy flowing into the batteries at that point. And then it goes into a absorption mode, and the absorption mode seems to take forever. And I can see where there's an amperage being drawn into the batteries or sent into the batteries. And then, but that slows down so much, and it seems like it takes forever to get those last few into and get it into float mode. What's happening there?
That's definitely something you're seeing of the lead acid battery. So you are correct. In bulk, in any battery type, they're taking as much charge as they can. And so from the charge controller or the inverter, it's pumping as much as it can into the batteries that they'll take. When it gets to absorb, it holds a constant voltage, so your absorb might be at 14.6 volts. At that point, to hold the constant voltage, it starts backing the amperage off. And lead acid batteries definitely do have a higher internal resistance, especially flooded lead acid. And so the absorb can take a significant amount of time to do that. And that's the part where it's topping off the batteries. Lithium bulk charge, 97, 98%, and then that last 2% goes fairly quickly and absorb. It still may be a little bit of time, but it's not nearly as long. And so what you're seeing there is that the battery is getting a little bit harder to get that last little bit of energy into them. And so it's slowing down the charge and it's pushing less amps into them and holding that constant voltage. And once they're full is when it should go to float, and then it's just holding a voltage you set for float, maybe around 13.6, and it's just holding the batteries there.
Okay. So in solar, you mentioned previously that sometimes when that slows down, people think that there's a problem with my solar install because things have slowed down, but it's really getting close to or into that float mode where it's just maintaining.
Correct. You'll definitely, in bulk mode, you should be producing, your max wattage the sun is producing at that time. And it depends on the time of day, but it should be, it could be anywhere from 60 to 85% of your solar system. But once you hit absorb, you're definitely going to see a decrease in the watts, and it'll probably drop off 30% or even less. And when it gets to float, it'll just be a fraction. So people sometimes panic when they say, my system isn't making that much wattage, and it's probably because your batteries are full and there's nowhere for that energy to go. Okay. And so it's just maintaining what you're trying to run at that time. And you could turn on a heavy load and you probably see it, maybe go back to bulk or just maybe jump up for a little bit.
Okay. Dan, thank you so much for this chat. You have helped me a great deal. So I sincerely appreciate that, and hope some of you out there in the virtual campground got something out of this. But I wanted to talk a little bit about, so personally speaking, and I'm sure there are others that feel similarly, I'm not going to take this on myself, and rvsolarconsulting.com is your business. So tell us a little bit about how you go about helping people like me do these installs.
So one of the first things they can do is reach out to me on my website, rvsolarconsulting.com, and I have a schedule a consultation, and I have a calendar, and they can pick the best time for them. I will contact them at that time, and usually our first conversation is talking about their needs, what they want to do with their solar.
That story you mentioned earlier.
Correct.
Tell me your story.
We're going to get their story. It's probably an hour consultation, usually what we do. And my main package most people do is, I call it a DIY solar package, and it includes 2 hours of consultation, a full design of their system, a shopping list, and a wiring diagram. Okay. And so we'll spend an hour kind of getting to know what their system is going to be. Then we'll probably exchange emails as I design their system, maybe ask them some questions if I need to about their rig, and send that to them. And once they approve the design, then we can submit that. And like I said, they can either, I have links if they want to go out by themselves and find the parts, or if they want to go through my supplier. I also deal with some battery vendors, Lion Energy UT1300s, lithium batteries I'm a rep for, and I'm working on other ones, hopefully in the near future. And once we get to that point, then we can order their parts and they can be shipped to them, and they can continue to consult with me for the install virtually. I'm happy to do video chats, email follow-up questions, that kind of stuff.
And there's just an hourly rate for that. So at that
Correct.
point, if they need help, then they just say, I need to schedule some more time with you to go through some questions.
Yeah, if we go past a 2-hour consultation, then we just schedule time, by the hour, and we work through that.
Okay.
And then I have some other options. Someone just wants to confirm a system. That might just be a quick hour chat, or if they just want to learn something about solar, I'm happy to do that with them. The other option that I've got mostly for the winter time because we got a permanent spot in the winter in Salome, Arizona. They can come to my location. Maybe they're, want to do the install, but they're not quite sure, and they'd rather have a little hands-on help or guidance. And so what I can do is offer them to come to my location, and they will be doing the majority of their install, but I'm there to assist them. I can walk over to the rig and say, this is your next section, A, B, C, D, do these steps, and I can get back in a couple hours. And I've already had some people take advantage of that, and it worked really well. Okay. And although I'm not focusing on installs right now, I may also do that this winter. I may line up some installs, but definitely can help people on site, and that's not taking up quite like a full install, but I'm there in different increments and they can walk through. And they have a place to ship parts to and get stuff.
Excellent, excellent. Well, thank you very much. So that's rvsolarconsulting.com.
Correct.
And so, yeah, hit that up. Check out his website. Lots of good information out there. And thank you so much for joining us. Really appreciate it.
Well, Barry, thanks for having me on the virtual campground.
Yeah, nice chatting.
Thanks.